In this video, we're going to talk about negative exponents in scientific notation. Whenever we have a negative exponent, we use what we call the reciprocal rule. Reciprocal rule. And basically the reciprocal rule states that for any non-zero base x, x to the negative n is going to equal some value. All right? It is actually going to equal 1 divided by x to the n. All right, and that looks like a reciprocal. Anytime we put a number over 1 or something over 1 or under 1 when we divide, we call that the reciprocal, and so that's why it gets the name the reciprocal rule. Let's look at a couple of examples where we use the reciprocal rule. All right. Rewrite using positive exponents and simplify. That is going to be one of the goals whenever we deal with algebraic expressions. We never want to leave our exponent as a negative. All right. The only time we're going to do that is when we have scientific notation. But besides scientific notation, whenever we have a variable with an exponent, we always want to write it so it will have a positive exponent using this type of rule right here. Let's go to 2 to the negative 5. Right. By the reciprocal rule, I know that I have to do 1 over 2 to the 5th power in order to make that 5 positive instead of negative. And of course, we can do 2 to the 5th power. That's multiplying 2 5 times, and that'll be 1 divided by 32. So 2 to the negative 5 power is 1 over 32. Let's go to part B, and this is one of those cases where we actually have a variable. I have 9 times x to the negative 6th power. In order for me to simplify that, I've got to do the reciprocal rule on that x, right? That negative 6 only applies to the x. So the 9 is going to stay the same, but I do the reciprocal rule in order to make that 6 an exponent that is positive, right? And of course, remember 9 is the same thing as 9 over 1, and so we multiply across. 9 times 1 is 9, and x to the 6 times 1 is x to the 6th. So my solution in simplified form will be 9 over x to the 6th. All right? And so that's basically using our reciprocal rule. I wrote this statement here. It says to make a negative exponent positive, kind of like what we do up here and what we did over here, use the reciprocal rule to remove or to move the negative exponent across the fraction symbol. All right, kind of like what we did here. If you think of this 2 to the negative 5, right? Remember, you can always write anything whole over 1. And so if I want to make this a positive exponent, then I move that number to the negative exponent to the denominator like I did right there. Same thing happened here, right? I can write x as x over x to the negative 6 as x to the negative 6 over 1. And so if I want to make that negative 6 positive, I move it to the denominator, right? That's all the reciprocal tells you to do, kind of flip it from where it is. And so let's look at a couple of examples where we use this. In this next example, it says rewrite without using negative exponents and then simplify. All right, we have x to the negative 12th over y to the negative 7th. And I'm going to go ahead and put my fraction symbol. Remember, in order for me to make that negative 12 become a positive 12, I got to move the x term to the denominator. So I have x to the 12th. And the same thing is going to happen to that y to the negative 7. Since it's negative in the denominator, I've got to make it positive by moving it to the numerator. And so I have y to the 7th over x to the 12th. Now that we're used to using these rules, I want to combine all the rules that we've covered so far in order to help us simplify expressions. For instance, in these next couple of examples, I have, well, in the first one, b to the 7th times b to the negative 19th. All right, before I start using that negative exponent type stuff, I'm going to use my other rules from the previous video to help me simplify. So here I have b to the 7 times b to the negative 19th. Remember, we have a power rule that says, hey, our product rule that says, hey, if our bases are the same, we add the exponent. So this is going to be the same thing as b to the 7 plus negative 19. And of course, 7 plus negative 19 is negative 12. So that's the same thing as b to the negative 12th power. And of course, we're always going to leave our answer using positive exponents, whether I say that or not. And then in order for me to do that, I use my reciprocal rule. I get 1 over b to the 12th. Okay. Our next example I have x to the 5th over y to the negative 4th in parentheses raised to the negative 4th power. Remember, we have a power of a quotient rule that says, hey, as long as I have division on the inside of that parentheses there, or if it was multiplication, I do the same thing. But I raise everything in that is in that division inside the parentheses to this exponent here. And so if I want to simplify this, I'm going to raise x to the 5th to the negative 4th power divided by y to the negative 4th to the negative 4th power. Of course, this is a power rule, and so whenever we raise a power to a power, we multiply the exponent, so that'll give us x to the negative 20th over y to the 16th. And then last but not least, I got to make sure that my exponents are positive. This one right here is not positive, so in order for me to make it positive, I need to move it to the denominator. And so my solution is not only going to have that y term in the denominator, since it is positive, it's going to stay there, but now that x to the 20th power goes into the denominator. And one thing you want to be careful about here is to not write 0 in the place of that. That'll be a 1, right? Remember, reciprocal 1 over something. And so that's a 1 always. Never put a 0 there. It's always going to be a 1. Now I'd like to talk about scientific notation. All right, scientific notation basically gives us a way to write really big numbers in a way that we don't have to use all of its digits. For instance, I have 1 million written here in standard form, right? That's the way we normally write 1 million. Well, if I want to write this in scientific notation, this is what it looks like. It looks like 1. We use the multiplication symbol that looks like an X, and I have 10 raised to some power. All right, always remember 10 raised to a power just basically give us our digits here. So 10 to the first power, 10 to the second power, 10 to the third power, so on and so forth, right? Scientific notation, if you want a definition, is any number that can be written in the form a times 10 to the b. All right, it's very important for you to know what a and b are in this definition. A is any number that's between 1 and 9.9 repeating, right? So no two-digit numbers are going to be here, right? It has to be between 1 and 9 point something. All right, B is any integer exponent, all right? And this is the time where I can have a negative because it's an integer, which includes negative numbers. So the only time that I'll leave an exponent as negative is if I'm using scientific notation. What I want you to be able to do is to convert from standard form to scientific notation and vice versa. And so let's look at how we go from writing a number in standard form, which is what we're used to writing a number in scientific notation. All right. In order to do that, we're going to move our decimal to make a number between 1 and 9.9 something, right? So here I started with 1 million. I've got to move my decimal, which is understood to be at the end here, to make this number between 1 and 9 point something, all right? When I do that, I'm going to count the number of positions, right? Because anytime I move my decimal to the left, right, or to the right, I'm doing a multiplication or a division. But I'm going to count the number of spaces that the decimal has moved. And then if the number was greater than 1, right, like 1 million, then my exponent on the B is going to be that same number of positions that I moved, and it will be positive. And so here, if you look at 1 million, I move my decimal, which is at the end here, 1, 2, 3, 4, 5, 6 places to the left in order to make that a number between 1 and 9.9 something, which I got here. And that was 6 places. And so since the 1 million started out being bigger than 1, when I write my times 10 to the exponent 6, it has to be a positive 6 instead of a negative 6, since this number was bigger than 1. All right. Had that number 1 million been less than 1, then I will make my exponent here negative. All right. Let's look at these two examples here. I have 320 billion. Right. Remember, your decimal is understood to be at the end if you don't see one there. And so what I'm going to do is I'm going to count the number of decimal places I move here. I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I need to go 11 decimal places in order for me to get a number between 1 and 9 point something. So that's 11 places. And so when I do that, I get 3.2. I don't need to write all those zeros. times 10. And since this number started out bigger than 1, that's huge, that's really bigger than 1, it's got to be a positive 11. All right, so I get 3.2 times 10 to the positive 11. Let's go to part B here. I have 0.000019. Again, I've got to move my decimal place. It starts here. This time, in order to make this a number between 1 and 9 point something, I got to go to the right. So I go 1, 2, 3, 4. That's not enough. I got to go 5. Right? So I went 5 places. And I end up with the 1.9 times 10, and my exponent here is going to be negative since this number started out smaller than 1. And so it's going to be to the negative 5th power. So that's going from standard form to scientific notation. Now, let's go in the other direction. I want to go from scientific notation to standard form, all right? Basically, all we have to do here is just move our decimal places either to the right or to the left. All right, we're going to move it to the right. All right, remember all of your numbers written in standard notation are in the form a times 10 to the b. Right, and so we're going to move the decimal to the right. Okay, if b is positive. All right, and b is the exponent on that variable. We're going to move our decimal to the left if b is negative. So let's look at these two examples here. That'll be 4.06 times 10 to the negative 8. All right. So I'm going to get that 4.06. And I've got to move it 4 places to the left. And I'm actually not going to have enough room here. So I'm going to rewrite that over here. All right, if I want to move it 8 places to the left, because remember, when I have a negative exponent here, that means my number is going to get smaller. It's small. It's less than 1. And that's another clue that I'm going to, instead of going to the right, I'm going to have to move my decimal place to the left, right? Because it's negative exponent. But here, 1, 2, 3, 4, 5, 6, 7, 8. Make sure you count your decimal spaces that you're missing and you fill in with zeros. So that's 1 0, 2 zeros, 3 zeros, 4 zeros, 5, 6, 7 zeros, then I have my 406. So my number written in standard form would be 1, 2, 3, 4, 5, 6, 7, 406. All right, and that is my answer in standard form. Let's go to part B in this example here. We have 2.88 times 10 to the 5th power. Again, notice that your exponent here is 5, which is positive. So you should think big numbers, bigger than 1, big numbers. And so if I try to move it to the left, you'll notice that your number will get smaller, right? Because you're going to have a decimal 0.0 something 28, right? And so I got to go to the right 5 units. And so I'm going to take that 2.88, go to the 5, right 5 units, 3, 4, 5, and my decimal will be right here. And again, fill in those zeros because they're always going to be necessary here. And so my final result will be 288,000. Okay. Now that we know how to convert between numbers in scientific notation, what I want to do now is to be able to multiply and divide numbers in scientific notation. We really don't add and subtract numbers in scientific notation because it basically uses a lot of digits. And with scientific notation, the purpose is to not be able to or not have to use all of the digits. But in any account, when we multiply and divide numbers in scientific notation, again, I always start by reminding you that any number in scientific notation is written in the form a times 10 to the b, right? And so what we have, when we have two numbers written in scientific notation, we're going to take the numbers that they have in the spot for a, multiply or divide them, depending on what problem we have, and then we're going to multiply or divide the 10 to the b parts of their numbers written in scientific notation. And so let's look at this first example here. I have 4.3 times 10 to the 16th times 1.6 times 10 to the negative 23, right? If I want to do this multiplication correctly by hand, I'm going to take the 4.3 and I'm going to multiply it by the 1.6. And then I'm going to take the 10 to the 16th and multiply it by 10 to the negative 23rd. And once I simplify that, I'll go ahead and have my number, and hopefully it'll still be in scientific notation by the time I finish. All right, but 4.3 times 1.6 is 6.88. And when I multiply the 10 to the 16th times 10 to the negative 23rd, I got to remember that I have to add my exponents, right? Bases are the same, you add your exponents. So all those rules from before still apply. That'll be 6.88 times 10 to the negative 7th power. All right, and once again, you want to make sure that when you finish that your numbers are written in scientific notation. Notice 6.88 is in scientific notation for A. That's the right form for A because it is a number between 1 and 9 point something. And I have times 10 to the negative 7. That negative 7 exponent is fine because we can have negatives when we're dealing with scientific notation. So this is, in fact, my solution. Let's go to part B, which is a division type problem. Give me some space here. I have 1.598 times 10 to the negative 12 divided by 4.7 times 10 to the 9th, right? When I do my numbers in scientific notation, do this division here, I'm going to take the 1.598 and I'm going to divide it by 4.7. And I'm going to have that multiplied by 10 to the negative 12 divided by 10 to the 9th. Okay? All right, definitely do that division, right? 1.598 divided by 4.7 is 0.34. And of course, with these exponents, we subtract them. I have negative 12 minus 9. And so we get 0.34 times 10 to the negative 21st power. Okay, now I got to check to make sure that my numbers are in scientific notation, right? Notice here, I have 0.34 in the spot for A. That is not written in scientific notation because that is not a number between 1 and 9 point something, right? That's in the right form, but this is not. And so what I have to do is I have to come up and think of what can I do to make this a number between 1 and 9 point something. And the thing to do is to move my decimal place one place to the right, right? So if I move my decimal place one place to the right, that's the same thing as multiplying by 10, all right? So I've got to multiply this 0.34 by 10 in order for me to make this a number in scientific notation, all right? And so if I multiply by 10, I'm actually changing the value of my problem. Remember, anytime in math, right, for instance, when we have an equation, we have to do it to both sides. Well, this isn't an equation here, right? And so if I'm working with something that's not an equation and I multiply by a number, then I also have to divide by the same number to keep it in an equivalent statement. So not only do I have to multiply by 10, I also have to divide by 10. And I don't care how you write it. You can write it right here. And as you can see, if you wanted to, you can cancel those 10s out and it'll be the exact same problem. But remember, when you are dividing, right, all you have to do is do the division one single time. And so instead of dividing right here in this location, I'm going to come over here and do that division over here. That way, this number right here can be a number in scientific notation. So what I'm going to write it as is 0.34 times 10 times 10 to the negative 21st over 10, all right? And now, when I multiply the 0.34 by 10, I get 3.4, which is now great for scientific notation. And of course here, 10 to the negative 21st divided by 10, remember that's a 1 exponent there. And so when our bases are the same when we're dividing, we subtract our exponents. And so we get a final result of 10 to the negative 22nd power. And that concludes our video on this. Wait, actually, right before we go, notice I moved my decimal place one place to the right. If I would have went 2 places to the right, remember, anytime I go to the right, it gets bigger. That signifies that I'm doing a multiplication. But if I wanted to do 2 places to the right, then I want to multiply by 100, right? Notice there are 2 zeros in 100. And 100 is the same thing as 10 to the second power. So instead of multiplying by 10 right here, I would have multiplied by 10 squared. And I would have also had to divide by 10 squared. All right. And I can continue. If I want to go 3 places instead of 2 places, I multiply by 1,000, which is the same thing as 10 to the 3rd power. So on and so forth. All right. That's the conclusion of this video.